So now we'll solve this question by directly using the formula x bar is equal to m2 by m1 plus m2 into r. So we've been asked to find out the change in the displacement of mass m2 when m1 is moved by 2 centimeters. Now, as we discussed in the previous section, all of these calculations will vary according to the choice of your origin. So in this case, in a given a 2 mass condition where m1 is equal to 3 kilogram and m2 is equal to 2 kilogram, 3 and 2, I have considered m1 to be the origin. Okay, so when we fix m1 at x equal to 0 and measure all the distances relative to it, the position of m2 is then measured from this origin. Okay, so let's try to see the detailed version of this formula. How did we arrive at this? So if we were to put these given m1 m2 into a origin into a graph, we have a as the position of m1. I'm sorry, I should have mentioned it here. So we have m1 center of mass and m2, right? So we have m1 which is placed at a. So the position of m1 is always written as a in this example. M2 is the position of m2 is referred to as b. The position of center of mass is correspondingly referred to as c. The coordinates of m1 wherever mentioned is x1 y1. Coordinates of m2 irrespective of which the origin is mentioned as x2 y2, and the coordinates of center of mass of this system m1 system consisting of m1 and m2 is referred as x bar y bar. The distance between a and b, which represents the distance between m1 and m2, is taken as r. Now we know that by the formula for center of mass coordinates, x bar is equal to m1 x1 plus m2 x2 divided by m1 plus m2. Now the question comes, what is x1 and x2? So if you see, x1 y1 represents the coordinates of a, and where is a placed at? A is placed at origin. Therefore the coordinates here would be 0 and 0. Since m2's coordinates are x2 and y2, m2 being r distance away from m1, b being r distance away from a, the coordinate x2 should be equal to r. And since b is placed right on the x-axis, the y coordinate here should be equal to 0. Therefore, y2 is equal to 0. Now, if we have x1 y1 equal to 0 0 and x2 y2 equal to r comma 0, what is x bar y bar? m1 x1 plus m2 x2. x1 is 0, right? So m1 into x1 becomes 0 plus m2 into x2 becomes x2 is r plus m2 into r. So what we get is m2 into r divided by m1 plus m2. Now y1 is 0, y2 is 0 as well. So what we see here is m1 y1 plus m2 y2 becomes 0 plus 0. So y bar is equal to 0. Therefore, we can say that this system can be reduced. Excuse me. So this system can be reduced as one with two bodies, two particles, A and B, with the center of mass of A and B being located at m2 r divided by m1 plus m2. Okay. Now let us go to the question. The particle of mass m1 is moved towards the center of mass through a distance 2 centimeter. In order to keep the center of mass of the system at the original position. So let us first consider this towards the mass, moving the system towards the mass. So towards the center of mass. So we'll first analyze what is that moving implies in the graph. So when we have the when we have the particle A with mass m1 moving towards center of mass, so we have mass m1 here, it moved towards the center of mass C by a distance of 2 centimeter. it is given that the center of it is given the question that m2 will also move, right? M2 will also move. So we will have to consider the relative positions of A and B after this movement. So I have drawn two diagrams here, two graphs here, one which is before, the other which is after. Okay, now before we have the positions of m1 as A, m2 as B. Okay, after moving we have the positions of m1 as A dash and m2 as B dash and center of mass as C dash. Okay, so what are the coordinates of A1? X1 dash, Y1 dash. Coordinates of B dash, X2 dash, Y2 dash. Now what is the value of X1 dash and Y1 dash? See, since this particle is moved 2 centimeter along the positive x-axis, the coordinates of x1 dash here should be equal to 2, and since A dash is on the x-axis, the y coordinate should be equal to 0. Therefore, y1 dash is equal to 0. Similarly, we have B moving towards the center of mass. Therefore, B moves a distance towards the center of mass, say x. So what will be the coordinates of B dash? It will be r minus x comma 0. So you may have a doubt here. So let me just take you through the example, the calculation part here. See, when B is shifting towards the center of mass, right? When B is shifting towards the center of mass like this, when B has shifted like this, the new coordinate is actually the length of this segment B dash. So we can say that x2 dash, oh sorry, it should not be B dash, it should be this length OB dash. Why? Because we are measuring every length with respect to the origin O here. So x2 dash is actually equal to OB dash, and from the figure, from the geometry of it, we can say that OB dash is actually equal to this complete length OB minus, right, OB minus this small length BB dash, right? What is OB? Is the distance between origin and B, which is actually the earlier distance between A and B, which is R. What is BB dash? We don't know. That's the unknown value here. So BB dash is equal to X. So what is X2 dash? R minus X. Okay. In this graph, if we write down this findings here, so we have X2 dash is R minus X and Y2 dash is 0. Now what can we find out? Now we can find out the coordinates of C dash, which is X1 dash, which is X bar dash comma Y bar dash, right? But what is given to us in the question? It is given that the center of mass of the system is at the original position, which means this C dash is equal to C. And what is the value of C? It is m2 by m1 plus m2 into r. So we can say that x bar here is equal to m2 by m1 plus m2 into r. Now just to make sure that you get the concepts clear, let me just detail that portion one more time. What is x bar dash is equal to m1 x bar dash plus m1 x1 dash plus m2 x2 dash by m1 plus m2, right? What is x1 dash? It is 2. What is x2 dash? We found out to be r minus x. Now what is x bar dash is equal to? Is equal to x bar, because the center of mass has not changed, which is equal to m2 by m1 plus m2. Okay. Now just to make sure that just to declutter this, this is what primarily the question means. The new coordinates C dash, right, and the x coordinate of that, which is x1 dash, which is x bar dash, is equal to 2m1 plus m2 into r minus x, and that c dash is equal to c, which means the corresponding x coordinate should be equal to 0, should be equal. And if we equate the corresponding x coordinates, 2m1 plus m2 into r minus x is equal to m2r. m1 plus m2 will cancel from both the sides. Now 2m1 plus, if you can, 2m1 plus m2 into r is rm2, m2 into x is minus xm2 is equal to m2r. Now what will cancel here? rm2, m2r will cancel. So what we get is 2m1 is equal to xm2. We transpose minus xm2 here. So 2m1 by m2 is equal to x. Given in the question that m1 is 3 kilogram, m1 is 3 kilogram, m2 is 2 kilogram, 2 by 2 is 1, so the value of x is equal to 3, and therefore the mass m2 should move a distance of, my bad, this is not 2 centimeters, should move a distance of 3 centimeters. So the primary thing here is to understand this calculation. This graph here that we have overlapped with the previous one, wherein the positions were A at O and B here, C dash is at the same position, right? If you are able to understand this graph and the calculation, things will become really easy. Okay, so now that we've done the question based on considering M1 to be origin, what will be the next task? Would be to solve the same question using M2 as the origin.